Sequences and series. That's our topic for today. First up, we're going to write the first 5 terms of the following sequence. What that means that I'm looking for is I'd like to know what the first term is, and I'm going to call that A1. The second term I'm going to call A2, then A3, A4, and then of course A5. So this would mean that for my very first term, notice this is a sub n, meaning that n would be 1. So I'm going to perform this operation. I'm going to do negative 1 raised to the 1, because in this case n is 1, times 1 over 1 plus 1. Then I'm just going to simplify this and figure out what number that is. Negative 1 raised to the first is going to be a negative 1. So negative 1 times 1 over 1 plus 1, that is 1/2. So I've got a negative 1/2 for the first term. For the second term, my n is 2, and then you kind of get the hang of this. You just say negative 1 raised to the second, 1 over, my n is 2, so I'll do 2 plus 1 this time. And negative 1 quantity squared is going to be positive, and then 1 over 3. So what that negative 1 to the n power does is it alternates my sign. Negative, positive, my next one will be negative, then positive, and so forth. So I figure my next one's going to be negative, but I'm going to go ahead and plug it on in anyway. Negative 1 raised to the third times 1 over 3 plus 1. So this is going to be negative 1/4. I think the next one will be positive 1/5, just looking at the pattern, but you can go ahead and plug it in. And then a sub 5 is going to be negative 1/6, just looking at patterns and following along with that. The next kind of problem they're going to ask you to do is to write the nth term of the sequence. I noticed that so that means when I get finished, I want it to look like a sub n equals. And so I just kind of have to fiddle with it a little bit, figure out what's going on, look at the pattern. I see that it's going from positive to negative, positive, negative. So it's some sort of negative 1 to a power. Now, negative 1 to the nth power, if n starts at 1, that won't really work because the first one would be negative. But if I say, let's just do n plus 1, n minus 1, whichever I just happens to suit my fancy, that would work, because if n is 1, I'd have negative 1 squared, so that would be positive. The next one would be 2, making that odd, so I'd have a negative, and so I'm okay with that. So I've got my alternating negative. Now I've got to figure out what's going on with my numbers. Just looking at the numbers 2, 4, 6, 8. Oh, this is just counting by my even numbers. So that's going to be 2 times n, I believe. If n is 1, it would be 2. If n is 2, it would be 4. And what I do is just kind of double check. I just go, okay, does this work? If n is 1, I would have negative 1 to the 1 plus 1 times 2 to the first. Is this going to give me 2, which it does? A sub 2, and check several of them. I'm only going to check a couple here just for time's sake, but I generally will check several of them just to make sure that I've got it. And of course I think I have this one. The next type of sequence I'm going to look at are recursive sequences, and in a recursive sequence the next number depends on the first number. So I'm given a sub 1, I've got to come up with a sub 2, a sub 3, a sub 4, whatnot. They give me the formula. Here's my formula, and it says this a sub k plus 1 says the next term equals 2 times the quantity the previous plus 1. That's basically what this says. So in this next number that I'm going to do, I've got k is 1, so you'll notice that it's 2 times the previous, which just happened to be 2 plus 1. So this is going to be 6. A sub 3 is my next one, and that's going to be 2 times a sub k, which is the previous, 6 plus 1, and this is going to be 14. The next one, a sub 4, is 2 times the previous plus 1. And that's going to be 30. And then a sub 5 is going to be 2 times the previous plus 1. And that's going to equal, let's see, that would be 31, 62. On writing the nth term of a sequence, you're once again supposed to fiddle around with it until you can figure out some sort of formula where you can write a sub n equals. So meaning that I really want everything to depend on the first. So what I start doing is I start looking to see how these numbers relate to the 2. And for the first little thing here, let's see, it looks like I added 4. From here to here, there's a 12. From here to the 30, I think that would be, 28. Then from here to the 62, that would be a 60. Now these require a bit of practice and really, fiddling around with them and trying to figure out how the numbers relate is a bit of an art, and it's kind of trial and error, and you just start figuring out a little tool basket of what you're going to look at. I'm looking at this one, and what I see are powers of 2 minus a number. I kind of look at this, and I'm going to see, well, that would be like 2 to the 3rd minus 4. This would be 2 to the 4th minus 4, because I'm looking at 8, 16, 32, 64. Notice that these numbers all kind of relate to each other as powers of 2 but minus 4. So after some finagling around with it, I kind of figured out that I could do 2 to some n plus 1 minus 2, and that would get me a formula that works for everything. Now, I had to check it and make sure that that worked, and starting with a sub 1, if n was 1, that would be 2 to the 2nd minus 2. Now I'm going to check 4 minus 2. That is 2, and that corresponds with this guy. So that works. A sub 2 equals, and that's going to be 2 to the 3rd minus 2. So that would be 8 minus 2. And that corresponds with my 6, which is next. And if you check all the rest of them, that worked. So for this one, I would choose. And are there others? Yes, you could choose others. But this was the one that I kind of chose after fiddling around with the numbers for this one. Alright, the next video I'll be doing arithmetic sequences and also another video on geometric sequences. This is just an intro to sequences. Thank you very much.